Hi, this video continues our comparison of vectors and linked lists. The previous video looked at time efficiency, how fast these things are. This video looks at space efficiency, meaning how much memory they use. So remember, what we're building up to here is some kind of scientific approach to deciding between the sequence data structures, those being vector, singly linked list, and doubly linked list. We're trying to do this based on evidence and reason. The previous video went into time efficiency, meaning speed. This video is looking at space efficiency, or how many bytes of memory these data structures use. First, a word on how we're going to measure that. We haven't really looked carefully at space efficiency or memory use so far. So we're going to use a unit of measure called a word. This is common in computer science to measure storage in terms of words. And a word is one element of the data structure or one pointer in memory, or maybe the size of something. And we're going to suppose those are the same size just to make these kind of calculations simple. You know, if you have an array of ints, those might take a different number of bytes than an array of doubles or strings or something. But to keep it simple, we're going to say one word is either one element of data or one pointer. So, for example, if you have a 64-bit CPU like most personal computers now, then a word would be 64 bits of memory, which is 8 bytes. And on a 32-bit CPU, which were more common in the past, then a word would be 32 bits, which is 4 bytes. 16-bit CPU, the same pattern is, that would be 2 bytes. And n is the variable for the number of elements currently in the data structure, as usual. What we're going to do is count how many words of memory each data structure uses as a function of n. So for a given number of elements n in the data structure, how many words of memory does that structure use? This is kind of like combinatorics in mathematics. So if you're familiar with that kind of math, this will be familiar to you. Now let's get into the three data structures. First off, the vector. So remember that the way that a vector works is it's a partially filled array. N is the number of elements actually in there, and n has to be less than or equal to the capacity. The capacity is the actual size of the storage array, and we allow the capacity to be up to 2n. So our array is always at least half full, so at least 50% of the capacity is in use. That means that if n is the number of elements, then the largest the array could ever be is 2n. So if each element is stored in one array location, that means we have a maximum of 2n words of memory used by a vector. So that means that a vector uses somewhere between 1 and 2 words per element. If you have a completely full array where the capacity and n are the same, then the vector uses exactly 1 word per element, very efficient, very compact. And it can be a little bit more wasteful than that, but the most wasteful it will ever be is a maximum of 2 words per element when you're in this moment where you have only 50% of the elements in use. Okay, now let's look at the singly linked list. So every node has one element and one next pointer. So in the structure here, the 7 node, for example, uses 1 word of memory for the 7 and 1 word of memory for the pointer. So we're using exactly 2 words per element. It's not a range, it's always exactly 2. And then a doubly linked list is 3 because every node has the element, that's 1, a next pointer makes 2 words, and a previous pointer makes 3 words. So you have exactly 3 words per element in a doubly linked list. So here's how they compare all in one table. The vector uses somewhere between 1 to 2 words per element. Singly linked list always uses 2. Doubly linked list always uses 3 words per element. And so what can we conclude? Well, the vector is the most compact for sure because it uses somewhere between 1 to 2. And the singly linked list is second best. It uses 2 words per element. Doubly linked list is the worst. It uses 3 words per element. So that says if space is critical, if the most important factor to you is how much memory one of these data structures uses, you should go with the vector because at its best, it uses only 1 word per element, which is half as much as a singly linked list and a third as much as a doubly linked list. Even at its worst for the vector, it's tied with singly linked list. And most of the time, vector will be less space than either linked list. In general, then if space is not your most overriding concern, it's just a general purpose data structure, still on the basis of size, vector is the best choice. Only use a singly linked list if that extra space can be justified. So we're using up more memory for a singly linked list compared to a vector. There should be a good reason for that. If we do need the extra operations that singly linked lists can do faster, then that's justified. But if not, then that's a pointless waste of memory. And the same goes for doubly linked lists. Doubly linked list uses even more memory than singly linked list, so there better be a reason if we're going to use that memory.